I've got some coin. I want to test the hypothesis that the coin is fair against the alternative hypothesis that it's biased in favor of heads. I'm proposing the following test. I'm going to toss the coin 7 times. I'm going to reject the null hypothesis that the coin is fair if I get 5 or more heads in the 7 tosses. Okay? If the null hypothesis is true, what is the probability distribution of the number of heads I get in those 7 tosses? Okay, it's binomial, right? It's like draws. If the coin is fair, it's as if I am drawing tickets with replacement from a 0-1 box that has 1 ticket labeled 1, 1 ticket labeled 0. I'm drawing from that box a fixed number of times, 7, right? I'm drawing independently each time. So I'm looking at the number of tickets labeled 1 in a fixed number of independent draws from a 0-1 box. That is the definition of a binomial, right? And the parameters of that are, of the binomial in this case, would be n equals 7, p equals 50%, a half. Okay? Okay, what is the significance level of this test? Right? What's significance level? What does it mean? Chance that we reject the null hypothesis when the null hypothesis is in fact true. Okay? So if the null hypothesis is in fact true, then the number of heads we get has a binomial distribution with parameters n equals 7 and p equals a half. And we reject the null hypothesis. This test says reject the null hypothesis if you get 5 or more heads in the 7 tosses. So we're going to reject the null if x is greater than or equal to 5, where x is the number of heads we get in the 7 tosses. So what we want to know is, what's the probability that x is greater than or equal to 5, given that x has a binomial distribution n equal 7, p equal a half distribution, right? So what is the probability that x is greater than or equal to 5 if x has a binomial distribution with n equals 7 and p equal a half? Well, it's the chance that you get 5 heads or 6 heads or 7 heads, right? That's how you get greater than or equal to 5. Okay, so that is then the sum from x equals 5 to 7 of, out of the 7 tosses in all, we need to get x heads. Yes? And the chance that that happens is we have chance a half for each of the heads. They're independent, and we have a chance a half for each of the tails, of which there have to be 7 minus x. And in fact, a half to the x times a half to the 7 minus x is just a half to the 7th, right? Because this coin's fair. Okay? So we have to add those 3 numbers together. There's some quizzical looks here. Is this, we don't like the summation sign. We want to work it out. Okay, so we got 7 choose 5 times a half to the 7th plus 7 choose 6 times a half to the 7th plus 7 choose 7 times a half to the 7th, right? That's what this is shorthand for. And what's 7 choose 5? What's a half to the 7th? Let's go. Half to the 5th is a 32nd. So we've got a 64th, 128th, 1 over 128. Yeah? Okay. So that's in all of these. Yeah? So what do we got? We've got 1 over 128 times a sum. 7 choose 5 is going to be 7 times 6. The rest of them get canceled by the 5 factorial. And then we have over 2 times 1. Okay. So that's 7 times 3, which is 21. Plus 7 choose 6 is 7, plus 7 choose 7 is 1. Okay, so this is equal to 29 over 128.